Hello students, today we are going to talk about the nucleation and growth in metals when metal solidifies from liquid to the solid phase. So till now you have learned about the transformation from one phase to another phase, but you have not learned about the rate of transformation and how this transformations takes place. That's what we are going to discuss today. So the transformation, that is the solidification from liquid to the solid phase, comprise of two processes. One is nucleation and other one is the growth. For the nucleation to be occurred, some critical nuclei are required that I am going to discuss in the next slide. That critical nucleus once formed, that leads to the grains, and by growing, that is called the growth process. So for example, this box is the liquid phase, and these blue dots are the atoms, and liquid is now at more than the melting temperature of that material. So we started decreasing the temperature, then the atoms started coagulating at some specific places that are called nuclei, started nucleating at some places, but the size is not optimum. With further decrease in temperature, the more atoms got coagulated at some specific place, and some are got distorted. Already coagulated atoms got distorted towards the another nuclei, and further decrease in temperature at some size is formed by coagulating these atoms. That size is called the critical radius. When the size of the coagulated atoms is more than or equal to the critical radius, then solidification starts at that point. Then that is called the nucleation site. So in this box now the two nucleation sites are there having radius. This dotted size circle is representing the critical nuclear critical radius, and when the critical radius is more than the critical nuclei radius, and the solidification starts. So from here solidification is initiated, and that is now I am representing by one circle. If once it is nucleated, then I am representing it with one circle, so in compromising of many atoms. So it started growing, but at another places some other nuclei are formed, so that's by formed and distorted, forms and distorted. But once its size is reached to the critical nuclei size, then that site becomes the nucleation sites and the solidification sites. So no distortion is taken place at that specific place. So further decrease in temperature leads to the growth, and the R is becoming bigger and bigger as we decrease the temperature, and later on nucleated sites started growing further and finally growing further, and that finally leads to the fully solidification process. When these sites comes in contact with each other, that resulted in the grain boundaries, or when these sites are at the boundaries of this box, that also represents the grain boundaries. So the as much as the nucleation sites, that resulted into the number of grains. For example, 3 nucleation sites are there till the solidification, till the whole liquid solidifies, then the only 3 grains will be formed. So the nucleation rates depends on the number of nucleation events per unit volume per second. So the growth rate is the rate of increase of size of critical nuclei. So how this once this critical radii is formed, how fast this radii is increasing, how fast this critical nuclei is increasing, is called the growth rate. So the overall transformation rate, that is dx by dt, is the function of nucleation rate and the growth rate. So the growth rate or the overall transformation rate was initially slow, that is because of the less number of nucleations or lesser nucleation rate, so no growth is there. Then both are occurred, that is nucleation as well as the growth is occurred, so the overall transformation is more in between from the starting at the end. But at the end there is less liquid and there's less number of nucleations occurred. That's why it resulted in lesser growth overall transformation rate. Also, the second reason for the lesser transformation rate is the area required to grow for the critical nuclei that is restricted by the boundaries. So that also resulted in lesser overall transformation rates. So the nucleation is of two types. One is homogeneous and another one is heterogeneous. If the nucleation sites are homogeneously distributed in the liquid, then we called it is the homogeneous nucleation. If the nucleations are occurred at some specific place, not uniformly throughout the liquid, then we call it the heterogeneous nucleation. In most of the cases, the heterogeneous nucleation takes place. For example, the ice that started solidifies from the walls of that utensil, that is called that are the nucleation sites. So that resulted in the heterogeneous nucleation. Also, the casting process is the heterogeneous nucleation that started solidifying from the walls of the mold. And so in most of the cases heterogeneous nucleation is there, but homogeneous nucleation is very less, and that is very difficult to attain the homogeneous nucleation. Some specific conditions are required to attain the homogeneous nucleation. So that's what I want to discuss in this 3-minute video. Thank you.